Good morning, HVAC team, or I should say ISC team, for the Marshall Space Flight Center assessment, which is going to turn into an HVAC system assessment for multiple buildings at Marshall Space Flight Center. So we're recording this. I talked to Dr. Languri this morning. This is Monday morning, about 10 a.m. And I want you all to watch this as kind of a precursor to the pre-assessment meeting. But Dr. Languri and I went to Marshall last Thursday. We spent all day there and kind of got the lay of the land and figured out a lot of what we're going to be doing. And I've typed up some notes here, and I wanted to share all of this with you to kind of get you up to speed a little bit, because there's a lot of information to convey. And we'll talk more about this at the pre-assessment meeting we have at the hotel after dinner Tuesday night before we start the assessment on Wednesday morning. So let's see if I can get this thing there we go. Okay, so I have just kind of off the top of my head typed up notes. And I think this will be probably a 30-minute recording, and it's enough to get you up to speed so that you'll kind of understand the situation and what we've been asked to do. So Marshall Space Flight Center has someplace between 35 to 40,000 employees who pre-COVID used to come to the base to work every day. But guess what? Post-COVID, or I guess we're still in the middle of COVID, I get roughly 4,000 to 5,000 employees actually come onto the base and work in their offices. And the rest are working from home. So basically, they've got a campus. It's all spread out, but they've got probably as many or more buildings than Tennessee Tech has. And when you go in the buildings, they're virtually vacant. In fact, a lot of them, I think, don't have anybody in them, but they don't know for sure. They don't have any sort of occupancy sensor. So they have to assume right now that these buildings are occupied and they're operating under COVID protocols, which we'll talk more about. So down to the third note, facilities does not, and they don't know if this situation with these buildings being virtually vacant will ever change back to where the employees have to come back to their offices on the base. So it's just this big state of unknown right now. And they're trying to do their best to minimize the energy use and cost through there. We're working for the facilities people there. There are about, and we have a listing I'll put up, and I'm going to send you a scanned file, but I'm guessing, I haven't really counted them. I'm guessing that we have probably on the order of 20 to 25 buildings that they want us to look at in 2 days. It's probably not going to be possible. And Memphis has another list. So we can count them up, but it may not be quite that bad, but it's a whole bunch of buildings. And it's all the same thing. They're basically all office buildings. So this is not process stuff. This is HVAC. Bases operating under COVID operational protocols, which require the HVAC systems to operate 24 hours a day, 5 days a week. They apparently are shutting buildings down, or at least turning them back on weekends. I'm not sure if that's been a new change or whether they were able to do that through the height of COVID. I'm not real sure. But before COVID hit, these buildings, the HVAC systems were shut down. And they didn't just set them back, they shut them down at 5 p.m. and started them back. I seem to recall they said about 6 a.m. because that would give them an hour to get them back up and comfortable for people that came in at between 7 and 8. I think most people work 7 to like 4:30 or something, or maybe 8 to 4:30, whatever it was. but now they are conditioning them at least during the weekdays, 24 hours a day, 5 days a week. Okay, so Carl's our main contact there, and he is proposing to the management there that on buildings with a smoke evacuation system, and that's a special system with big exhaust fans that is really there in case they have a fire in the building. They're able to pull fire or smoke from the building very, very quickly and turn the air over very quickly in the building. But anyway, and about, not all of their buildings, but a lot of them do have these smoke evacuation systems. So he's proposing that they go back to the shutdown on the weekdays from 5 p.m. and then at like someplace around 5 a.m. instead of just the first thing being starting up the HVAC system, the first thing would be to turn on the smoke evac fans and completely purge all of the air out of the building. And so the idea there is he can guarantee to the safety people that if there was anybody in there that had COVID, and it's possible, well, they probably weren't working overnight if the HVAC was off, but they could have been in there the day before, and there could still be COVID in there. And so then they would run this purge, this HVAC system to purge all of the air from the building for whatever period of time. My calculation, I mean, I would think it would be between probably 20 minutes and an hour. And that'll be one thing that we'll want to evaluate is how long they need to run the evacuation fans in order to purge the building. And that's a simple calculation. You just take the volume of the building and the CFM of the fan and divide the volume by the CFM. And that tells you the number of minutes you have to run it in order to turn over that amount of air. So that's a simple thing. We just have to have the calculate the volume of the building and know something about the evacuation system. Another details here, they have a 1 million gallon chill water storage tank at the chiller plant that's used to store chilled water produced during off-peak electrical rate times in the electric rate structure. So as I say down here in this next bullet, the on-peak period for the most of the air conditioning season is 2 p.m. to 8 p.m. So that's where electricity and demand charges are much, much higher. And so the purpose of that tank is for them to run extra chillers during the off-peak time and make a whole bunch of cold water. I'm guessing it's about 40 degrees, 40, 42, and store it in that tank. And then when you come to 2 p.m., they turned off all the chillers and then they just pull that cold water out of the tank like the chillers would have made if they were operating. But since they have it stored, they don't have to run the chillers and they avoid the big electrical demand charges. And electricity is, the energy is probably a little more expensive during the on-peak period as well. So they have that system. Well, what they're finding is that with this new COVID operating scenario where they have to operate the buildings 24 hours a day during the week, that the tank is not large enough. And so they lose the ability to air condition effectively at between 5 and 6 o'clock at night. So they have to start at 2, but the tank is spent at between 5 and 6. And so then they have to turn chillers on and bingo, then they're setting higher demand peaks during the on-peak period, and they lose their savings for having that chilled water storage tank in the first place. So that's a lot of the motivation for us to be there, is to try to give them some projected savings if they could go to this purge scenario, at least on buildings that have the purge cycle, which might let them be able to ride through with the storage tank for the 6-hour period and not turn on the chillers until after 8 o'clock. So, extra complications. They do have a plan that they're trying to move through approvals and funding and all this stuff to put in a second 1 million gallon storage tank that would kind of alleviate this situation. And they feel like they need it anyway, but it's really been the financial impact of all this has come to the front with COVID right here for sure. There was discussion of some mold growth in a few of the buildings. We don't know how many. We don't know how bad it is, but that you get mold started in a building and it can be very expensive to remediate if you don't catch it really early, and it can be a big problem. And then of course you got environmental impacts from that as well. So that's of some concern. We say, or we saw, that should say we saw, I'll edit this after we get down here. We saw cooling air supply temps on a computer, in some cases, 48, 49, 50 degrees. Well, that's very, very cold coming off of an air handling unit. That's unusually cold. Usually design will be 55 to 58 degrees. There is a concept that circulated around about, I don't know, a number of years ago, 10, 15 years ago, called cold air distribution, where buildings were designed with these very low supply air temperatures for air conditioning in order to downsize ducts and fans. You know, if the air is colder, you don't need as much of it for a given load. And we've asked for copies of HVAC design, prints, sheets, which they have digitally, but they've not sent us any yet. Because, the only way you would know would be to check the design and see if this was really designed around 50-degree supply air temperatures, which I tend to doubt pretty severely, but I don't know until I see the prints. So we'll see. A lot of these buildings are what we call VAV, variable air volume buildings. And so the HVAC system has VFD on the fans. And these people have VFDs on everything. It's amazing. I've never seen a place that had so many VFDs in my life. We saw some air handlers that had VFDs on the supply fan. And so as what happens is you distribute out to these, they call them VAV boxes, that actually control the airflow to particular offices or spaces or conference rooms or whatever. And the thermostat controls the volume damper in these boxes. And so if it starts getting too cold, that volume damper will squeeze off the airflow to that box down to some minimum. And then if it still gets too cold, there's electric resistance strip heat in the box that will come on to keep the space from overcooling. And then of course, you might have, I don't know, 30, 40, 50, 60, 70 of these VAV boxes spread out through the building. And if they all start throttling back, then the fan will sense that, the pressure will go up in the duct, and the VFD will slow the fan down accordingly. Well, so if you're running this really cold supply air, with no load, no people, very few lights on, you would assume that the box would go to minimum position. And then if it was still too cold, you'd be heating it back up again. So it may be that they're cooling it down too cold so they can heat it up again later in the space. That's something else we'll need to try to look into. Let's see. Yeah, so I think I pretty well talked through all of the points on this slide. Let's see, they're also concerned, oh yes, the hydronic system, which is the chill water and the hot water that's supplied to the coils that actually does the conditioning of the air. Okay, so they think that they have a lot of valves that leak through when they're supposed to be closed. For example, if you have a hot water valve, and they may, I'm not sure if they're still supplying hot water to these things, but they're thinking that this water, even though the valve is, the control system has the valve 100% shut, that water is leaking through, and it could be that they're cooling down the the air and heating it up and cooling it down and heating it up. And also it could be that the chill water valves are leaking through. So we've got a bunch of additional thermocouple readouts, and we're going to try to evaluate some of this. We will have a walkie-talkie supposedly, and we'll call up to the control room and we'll tell them where we are, and we'll tell them, okay, close the chill water valve. And so they'll close it on the computer, and then we'll try to give it a few minutes and, you know, see if the air temperature changes, see if the pipe, you know, if we can detect a change in the temperature of the pipes, if we can get a thermocouple probe in there to try to figure out if the valve is leaking through. How this is going to go, I have no idea. We're just going to have to roll with the punches. Another idea is on some of these large air handlers that you can actually, you know, physically walk into, that we would take a vane anemometer in and a tape measure, and we would measure the cross-section area of the louvers, estimate the louver position, and try to measure the amount of outside ventilation air that was actually being pulled into the unit. I know we can do that on some of them. Some of them we probably won't have access on, and all we can do is the best we can do. There's also discussion of trying to determine how much air is being exhausted. At least some of these buildings have rooftop exhaust fans, and some of them are upblast and some of them are centrifugal. And we'll go up to the roof and we'll take our vane anemometers and we'll take our tape measures, and we'll go up there and we'll try to get the measurements so we can calculate what the exhaust airflow rate is where possible. So this is going to be an all HVAC system assessment. We'll also, you know, a long-term goal when we come back will be to build carrier hourly analysis program models. That's modeling software we have from carrier to predict what the energy savings would be if we went from 24/7 operation, which they're in now, to basically 24 hours a day, 5 days a week, 12 hours. So they would shut these systems down like they used to from, say, 5 a.m. to 5 p.m. So we'll try to use that software to make some projections on that. So there you have it. That's the end of that. Let me see here if I can get this down. Let me see. I think I have. Here we go. Ah, well, this is this is some invoice stuff. Let me see. I guess I haven't opened this. Let me get a file open here real quick. One that I just scanned. Here we go. Okay. So this is the building list. Let me rotate this thing and make it a little bit smaller. So it's 2 pages. There we go. And so these are all TTU buildings. Oh my goodness, look at all this stuff. And so we have tier 1, tier 2, and tier 3. So they want us to get through the tier 1 first, tier 2 second. And oh, here we go. This is TTU 1, 2, 1, 1, 1, 1, 1, 1, 1. And then here's our second page. So guys, you think we can do some of these buildings? Well, we got the square footage. You know, some of these things are pretty healthy. What is it? We went to this, I think we went to 4203. It was 234,000 square feet. 6-story building. Here, 4201. 110,000. This building is being demolished, but it's still on our list. This Mark Graham, you should note that he's not our lead contact, but he's probably the more technical of the people we talked with. And he does have some answers, and he can get screen captures and stuff from the control system for us. So you should note that we have that phone number. So at any rate, these are, and then DX means that these are like packaged systems. They're not chill water or hot water. They're just refrigerant based systems. They tend to be, the smaller buildings will be DX. The larger buildings will be on chill water. I'm not sure what this D means. I'm not sure. But anyway, this is what we're supposed to look at in 2 days. We may have to work all night. I don't know. We're not doing that. Okay. So this is, let me get this rotated around. Let's go around in a circle here. Okay, so this is an example of a screen capture. So for all of the air handling systems that are on the computer, which I think is most of them, we can get these screen captures. And so the idea here is that, you know, we'll look at some of these. We're supposed to have them before we go in, so I don't know if that's going to happen or not. But the way you look at, so this is the 3rd floor. So this is return air that's coming back. And it looks like, that looks like it's closed. So that would be if we're going to exhaust this air from the building, the return air. So if that's closed, then the return air has to come back into this chamber. This is outside air, ventilation air. And this is what we, if we can get in this chamber, this is what we would want to try to measure, get an idea, note the damper position and try to measure this. And if we're in there, we can measure this too. So these are just louvers that, like, if this one, the more open this is, the more closed this is, the more closed this is, the more open this is. That's kind of the way we do that. We can potentially go on free cooling with outside air with this, called an economizer cycle. So this looks like, I guess that's 91 degrees. I think this is a position. This is a smoke damper. So if you know, if they weren't going to purge the thing, then this would close and everything would be sucked out, I guess. We've got a couple coils here. This is 0. So I'm guessing this is a hot water coil. And then this is a chill water coil, but I'm not sure. 69.3. That could be a percent, that could be a temperature. It looks like that's probably a percent on the valve right here. Here's our fan. This, I guess, is our maybe a VFD setting. That may be 61.2% of maximum, but we're going to have to get some help to make sure we interpret these things right. And this, say, this is this supply temperature, 49.4 degrees with a set point of 50. That just blows me away. That's extremely cold. Unless that's now maybe that's a design. Maybe these are cold air distribution systems. I don't know, but that's awfully cold air. You can have, if the insulation's not really good, if moist air gets to the outside of this duct, it's going to condense and that water is going to drip on something. And this is static pressure. So this is the pressure in the duct. This is maintained by the VFD to make sure, because all these boxes are downstream of this thing opening and shutting. In this case, they're probably shutting if it's this cold with no load in the building. Anyway, so on this unit, these I think are VAV box numbers. It says minimum CFM of 0, but I find that, I don't know. I find that hard to believe that these things would go to shut off, because that's for ventilation. They usually don't let them go to shut off. primary CFM. So, you know, I don't know. I'm not sure how they've got this. Maybe they do have these shut off, but this one, max CFM is 500. We got 478. So maybe this is all the conditioning they're putting on the in this area. I don't know. We'll have to get verification on this. There's a lot to know about this. But anyway, this is pretty good information once we figure out how to completely digest it. This shows, this is the building we were in, 4203 environmental controls display. So these are all of the different air handlers, VAV system displays. Was this VAV? These are, I think, fan assisted terminal units, fan FTUs, fan terminal unit. So these are a little bit different. These have fans built into them. They can, I think they can recirculate return air into them. And so they can, the guy on the control system can click and get a different screen up for each one of these things. And then you can get a 4x4 display. So it's a 6-story building, a basement, which was, I'm not sure what all was down there. We saw there's a couple of air handlers and some mechanical rooms is what we saw. Yeah, so see, yeah, AH1 air handling, basement 1, 2, and 3. There was 3 down there, and then each floor 1 through 6. I'm not sure what 7, 8, 9 where they're located. So anyway, I also have displays on chilled water system, air handling unit summary, fire display, exhaust fan, so lots of stuff. Okay, and then we did go to the central chiller plant, which looked to be extremely well run. So this was just, we mentioned the central chill water plant, so they printed this screen out and gave it to us. But they've got VFDs on just about everything. They had a big 5-cell cooling tower, had VFDs on all of those fans, and they seemed to be being reasonably controlled. While we were there, we probably spent 30 minutes walking around the chill water plant. But we had thought about maybe going over there and including that in the assessment. But after seeing it, and seeing all the other stuff that we got to look at, it looks to me like we may take a tour of this just so that you can see it if we can scrape up some time. But I don't think there's a lot for us to dig in. It looked to me like this was being pretty well operated, at least at a cursory level. Okay, so I think that's the end of my rambling here. I'm going to go ahead and cut this thing off. I'll post it on my YouTube channel and send you all links. So please listen to this. I'll also send you the files, and this is a start on the pre-assessment meeting. So appreciate your time. Hope everybody has a great day and didn't get too tipsy or blow off any fingers on the 4th of July celebration. See you guys tomorrow. Bye.